Kombucha is a probiotic drink made from tea, sugar, and live bacterial culture, also known as a SCOBY, or a symbiotic colony of bacteria and yeast. Because many different microorganisms are at play, both alcoholic and lactic fermentation occur. This leads to an acidic flavor and slight fizz, with a small amount of alcohol produced. Kombucha has seen a rise in popularity in recent years, with public awareness growing on the importance of the gut microbiota for overall health. Kombucha is primarily thought of as a refreshing drink that doubles as a health supplement. Many people consume kombucha for the supposed health benefits and effects. Health benefits from kombucha can come in the form of antioxidants, vitamins, and minerals. However, most of the health benefits of kombucha lie within the diverse microbial community within it. Beneficial bacteria or probiotics found in the kombucha can have positive impacts on health. First and foremost, it's important to note one of the most important bacteria in kombucha, one that aids in the development of the SCOBY. The SCOBY is a cellulose mat produced by Kombucha bacter, which turns glucose into cellulose. This cellulose mat is essentially a starter, similar to a sourdough starter. The SCOBY acts as a host for many different microorganisms, especially beneficial bacteria. This cellulose mat may act as a barrier between the kombucha and any potential contaminants, such as dust and other microbes. These bacteria can impart certain health benefits in the kombucha due to their probiotic potential, as well as alter the characteristics of the finished product. The first and most prevalent bacteria found in the sample of kombucha is Arthrospira. While you may not immediately recognize the name, Arthrospira is a common supplement and food additive, better known as spirulina. Spirulina typically has a neutral to grassy taste, with no odor in most cases. Archaeological records show that spirulina was harvested by the Aztecs and other Mesoamerican cultures dating back as early as the 15th century, where spirulina would be sold as dried cakes for consumption. Arthrospira is able to capture light and carbon dioxide to synthesize a spectrum of organic substances, including proteins, unsaturated fatty acids, and polysaccharides. This blue-green algae is a biomass of cyanobacteria that boasts the highest protein content of any food, up to 70% protein content in the dried form. While eating large quantities of spirulina isn't necessarily feasible, it is still considered a superfood for its vitamins, minerals, antioxidants, and carotenoids. Research points to spirulina being a potentially potent natural pharmaceutical, having the ability to lower blood lipids, resist oxidation, combat infection, fight against cancer, radiation, and aging, while enhancing the body's immune system. Several studies suggest it has the potential to fight against neurological disorders, including Alzheimer's. Spirulina is widely used in the food industry for many reasons, ranging from coloring agents to biofilms. Today, Arthrospira, or spirulina, is the most cultivated algae in the world, with several countries having commercially available spirulina. It is most often sold in dried forms in the form of tablets, powders, and tablets. However, when exposed to conventional processing, which includes harvesting and spray drying, spirulina loses many of its nutritional properties due to high temperatures. The drying and spraying process is also a costly process, accounting for 30% of production costs. The spirulina may experience protein degradation, pigment oxidation, and Maillard reactions that lead to nutritional loss. A raw, unprocessed form of spirulina, such as that found in the sample of kombucha, may prove to be a superior form of spirulina supplementation, as opposed to the current status quo for spirulina intake. Current spirulina production facilities utilize the open raceway pond system, which maximizes the biomass production and extends the annual production period of spirulina. These systems utilize natural lighting and paddle wheel mechanisms to ensure mixing and provide liquid flow, maximizing light exposure for Arthrospira. Because these systems are made in open or partially open environments, they can be susceptible to contaminants such as rainwater, dust, bacteria, and zooplankton. These can impact the safety and quality of the finished spirulina. The cultivation of fresh spirulina differs in several key ways. Production is done in a closed system environment known as photobioreactors. Here, light intensity, nutrients, temperature, and gas composition can be controlled to ensure maximal algae mass. Because of its resource cycling ability, Arthrospira can have applications in life-supporting systems, such as space stations and submarines. Utilizing light, Arthrospira can absorb carbon dioxide and release oxygen, maintaining air quality in closed systems. Furthermore, Arthrospira biomass, or spirulina, can be an important nutrient source, providing proteins, vitamins, and minerals in a system where deficiencies are common. Because fresh spirulina does not undergo the same thermal pasteurization techniques as dry spirulina, alternative decontamination is necessary to reduce the risk of foodborne pathogens. Some technologies include pulsed electrical fields, ultrasonification, ozonation, and cold plasma. Arthrospira are filamentous cells, and they are composed of amino acids that mirror those essential to human bodies. One of the most active ingredients in Arthrospira is phycocyanin, which also lends to much of the health benefits associated with the genus. Unfortunately, Arthrospira cells rupture under high temperatures, potentially losing much of the phycocyanin content. Fresh spirulina can preserve the complete cell structures necessary for maintaining phycocyanin. Studies have shown that phycocyanin is strongly associated with or even proven to neutralize radicals in the body and reduce oxidative stress to prevent chronic disease, constrain tumor growth and spread, alleviate allergies by reducing histamines in mice, and reduce chronic inflammation. Arthrospira cells are derived from plants, and therefore the cells and cell walls are a type of crude fiber. The cell wall has characteristics of a gram-negative bacterial cell wall. The cell wall is primarily composed of peptidoglycan and polysaccharides. These polysaccharides are considered prebiotics, as they pass through the stomach and provide nutrients for beneficial intestinal microflora, enhancing the immune system, intestinal inflammation, and digestion. The cell wall also contains magnesium, calcium, and zinc, which can be released by the intestine and are absorbed by the body. Spirulina is often used in functional foods or products that promise additional health benefits besides the nutrients naturally available. Other industrial uses are being researched, such as spirulina bread, where its water retention properties are being studied. Despite Arthrospira being found in this kombucha sample, it is not typically found in kombucha. This is an interesting discovery, as the primary bacteria found in kombucha are typically consistent across batches and include other bacteria such as lactobacillus or Bacillus coagulans. This could signify introduction of Arthrospira in the kombucha somewhere in the production process, or intentional addition of spirulina cells by the manufacturer for its health benefits, or to act as a prebiotic for the other beneficial bacteria in the kombucha,